acid. Plain introduction, main part, chemical characteristics, applications of acids, common acids, conclusion, literature. Acid. An acid, a chemical which, when added to water, increases the amount or concentration of hydrogen ions or hydrogen, making it acidic. Hydrogen ion, hydrogen is just an atom without its electron, and as a hydrogen atom is just one electron and one proton, the term hydrogen ion can be used interchangeable with proton. General properties of acids. They are liquids, they have a sour taste like vinegar, they have a sticky texture, they have a sharp smell that can burn your nose, they turn litmus paper red. Яғни бұл дегеніміз бізде қышқылдар, олардың өзіндік бір иісі болады, мұрынды күйдіретіндер, және олар жабысқақ болып келеді. Көпшілігі сұйықтық және де литмус қағазының қызылға бояйды. Classes of acids: weak acids, strong acids, inorganic, organic, hydroxide, oxyacids, dilute acids, concentrated. Preparation of acids. Strong acid preparation. Hydrogen chloride is made by the chlor-alkali method. This involves electrolyzing a solution which produces hydrogen gas and chlorine gas and UV light. These gases combine to form hydrogen chloride can also be made by taking advantage of acid boiling points. Mixing, which has a higher boiling point than which the salt of hydrogen chloride generates. Sulfuric acid is made by first burning sulfur with oxygen to generate, then is converted sulfur trioxide in the presence of vanadium oxide catalyst. Finally, so is mixed with water to produce other oxides like carbon dioxide reacts with water to form carbonic acid. Weak acid preparation. Acetic acid is primarily made by carbonylation. In this process, methanol and carbon monoxide react in the presence of a catalyst to produce acetic acid. A small amount of acetic acid is made by bacterial fermentation, which metabolically converts sugars like glucose to acetic acid. Source of acid: lactic acid, acids and their sources, grapes tartaric acid, tomato oxalic acid, lemon citrus acid, vinegar acetic acid, apple malic acid, and formic acid. Modern definitions are concerned with the fundamental chemical reactions common to all acids. Most acids encountered in everyday life are aqueous solutions or can be dissolved in water, so the Arrhenius and the Bronsted-Lowry definitions are the most relevant. The Bronsted-Lowry definition is the most widely used definition unless otherwise specified. Acid-base reactions are estimated to involve the transfer of a proton, hydrogen, from acid to a base. Hydrogen ions are acid according to all the definitions. Although alcohols and amines can be Bronsted-Lowry acids, they can also function as loose bases due to the lone pairs of electrons on the oxygen and nitrogen atoms. Arsenous acid. In 1884, Science Arrhenius attributed the properties of acidity to hydrogen ions. Let's describe it as protons or hydrons. And Arrhenius acid is a substance that, when added to water, increases the concentration of hydrogen ions in the water. Note that chemists often write and refer to the hydrogen ion when describing acid-base reactions, but the free hydrogen nucleus, a proton, does not exist alone in water. It exists as the hydrogen ion or other forms. Thus, an Arrhenius acid can also be described as a substance that increases the concentration of hydrogen ions when added to water. Examples include molecular substances such as hydrogen chloride and acetic acid. Acid react with metals and carbonates. Metal plus acid equality salt plus hydrogen. Magnesium plus hydrochloric acid equality magnesium chloride plus hydrogen. Acid plus carbonate equality salt plus water plus carbon dioxide. Acid, hydrochloric acid, hydrobromic acid, nitric acid, nitrous acid, sulfuric acid, sulfurous acid, carbonic acid, phosphoric acid, perchloric acid, chloric acid, chlorous acid, hypochlorous acid, acetic acid. Organic acids, carboxylic acid functional group. Carboxylic acid are readily deprotonated by bases such as this reaction is product favored as the product are more stable than the reactants. The conjugate base is much more stable than the base, therefore Bronsted-Lowry acids. While the Arrhenius concept is useful for describing many reactions, it is also quite limited in its scope. In 1923, chemists Johannes Nicholas Bronsted and Thomas Martin Lowry independently recognized that acid-base reactions involve the transfer of a proton. Bronsted-Lowry acid is a species that donates a proton to a Bronsted-Lowry base. Bronsted-Lowry acid base, though, has several advantages over Arrhenius theory. Consider the following reactions of acetic acid. The organic acid that gives vinegar its characteristic taste. And Lewis acids, as such, only marginally related. Concept was proposed in 1923 by Gilbert Lewis, which includes reactions with acid-base characteristics that do not involve a proton transfer. Lewis acid is a species that accepts a pair of electrons from another species in the world. It is an electron pair acceptor. Dissociation and equilibrium reactions of acids are often generalized in the form. The strength of an acid refers to its ability of or tendency to lose a proton. A strong acid is one that completely dissociates in water. In other words, 1 mole of strong acid dissolves in water, yielding 1 mole of hydrogen and 1 mole of the conjugate base and none of the protonate acid. uh, monoprotic acids. Monoprotic acid, also known as monobasic acids, those acids that are able to donate one proton per molecule during the process of dissociation, as shown below.